Welcome to this comprehensive guide on code optimization for beginner developers, focusing on Visual Studio and Unity 3D. This guide will provide you with essential tips and techniques to enhance the performance of your applications and games, ensuring a smoother and more efficient development process from the very beginning of your coding journey. Code optimization is the systematic process of improving code execution efficiency, significantly reducing resource consumption like CPU and memory, and ultimately enhancing the overall performance of your software. It involves refining your code to make it run faster, use fewer resources, and deliver a better user experience. For beginners, understanding this fundamental concept is the crucial first step towards building better applications and games. Grasping the principles of optimization early on will lay a strong foundation for developing high-quality, performant software throughout your career. Optimized code leads to a multitude of benefits, including faster execution times for your applications, significantly smoother gameplay in Unity 3D projects, reduced battery usage on mobile devices, which is vital for user satisfaction, and improved scalability for your projects, allowing them to handle more users and data efficiently. Visual Studio provides powerful profiling tools specifically designed to identify performance bottlenecks within your code. These tools allow you to analyze CPU usage, memory allocation patterns, and even database interactions, giving you a comprehensive view of where your application might be struggling. The Diagnostic Tools window within Visual Studio offers real-time insights into both CPU and memory usage during your builds and debugging sessions. This immediate feedback helps you pinpoint specific areas in your code that are consuming excessive resources, making it easier to identify and implement improvements. The Unity Profiler is an essential tool for monitoring your project's performance in real time, providing detailed information about various aspects of your game. It helps you spot bottlenecks by showing precise task durations, memory usage, rendering statistics, and overall frame rate, allowing for targeted optimizations. Additionally, the Stats window in Unity shows real-time rendering statistics, which are crucial for optimizing graphical performance. This window provides immediate feedback on draw calls, triangle counts, and vertex counts, helping you understand the rendering load and make informed decisions about visual assets. Unity's Frame Debugger gives you a detailed, step-by-step overview of what the GPU is doing each frame. This powerful tool aids in advanced rendering optimizations by allowing you to inspect every draw call, shader pass, and texture binding, helping you understand and improve your rendering pipeline. Writing clean, efficient code is paramount for optimal performance and maintainability. A key practice is to break down complex logic into smaller, more manageable, and reusable methods or scripts, which not only improves readability, but also makes your code easier to debug and optimize. Upgrading to a 64-bit version of Windows significantly expands the virtual memory available to Visual Studio, which can dramatically improve performance, especially when working with large projects or complex solutions. This increased memory capacity allows Visual Studio to handle more data and processes simultaneously, leading to a smoother development experience. Regularly updating Visual Studio and Unity is crucial to benefit from the latest performance enhancements, bug fixes, and new features. Software updates often include critical optimizations that can directly impact your development workflow and the performance of your applications, so staying current is highly recommended. Ensuring proper project setup by choosing a suitable working directory in Visual Studio can significantly improve indexing and overall performance. A well-organized project structure helps Visual Studio efficiently manage files, leading to faster load times and a more responsive development environment. In Visual Studio, you can boost performance by disabling unnecessary features like automatic file restore, code lens, and the diagnostic tools during debugging sessions. These features, while useful, can consume resources, and temporarily deactivating them when not needed can lead to a snappier development experience. To reduce the impact of antivirus scans on Visual Studio's speed, it's advisable to exclude project files, app data, and program files folders from real-time scanning. Antivirus software can sometimes interfere with development tools, so configuring these exclusions can prevent slowdowns during compilation and execution.
Optimize build performance by enabling parallel builds, a feature that leverages multi-core processors to significantly speed up the compilation process. By distributing the build tasks across multiple CPU cores, you can drastically reduce build times, especially for larger projects, leading to a more efficient workflow.
Utilize VS Code IntelliCode for AI-assisted IntelliSense, which provides highly recommended completion items tailored to your specific code context. This intelligent feature learns from your coding patterns and common practices, offering more accurate and relevant suggestions that can accelerate your coding speed and reduce errors. Customize VS Code settings, such as enabling bracket pair colorization and emmet, to further enhance your development workflow and performance. Bracket pair colorization improves code readability by visually distinguishing nested brackets, while emmet provides powerful abbreviations for quickly generating HTML and CSS, both contributing to a more efficient coding experience. Leverage Visual Studio's robust refactoring support to write cleaner, more maintainable C# code with ease. Refactoring tools allow you to rename variables, extract methods, and reorganize code structures automatically, ensuring consistency and improving the overall quality of your codebase without introducing new bugs. For collaborative debugging and real-time code editing, use Visual Studio Live Share, which enables seamless cooperation with other developers. This powerful feature allows multiple team members to work on the same codebase simultaneously, sharing debugging sessions and instantly seeing each other's edits, fostering efficient teamwork. In Unity 3D, it is highly recommended to cache references to components and game objects at initialization, typically in awake or start methods. This practice avoids repeated, costly function calls like getComponentT during runtime, which can significantly impact performance, especially in frequently updated scripts. Implement object pooling to efficiently reuse objects that frequently appear and disappear in your game, such as bullets or enemies, instead of constantly creating and destroying these objects, which consumes significant CPU and memory resources. Object pooling allows you to activate and deactivate them from a pre-allocated pool, leading to smoother performance. While LINQ offers a clean and expressive syntax for querying data, it generally requires more computation and memory overhead compared to traditional loops. For performance-critical sections of your code, especially in Unity, consider writing manual algorithms to achieve better efficiency and reduce garbage collection impact. Set the static property on non-moving objects in Unity to enable internal optimizations like static batching, which significantly reduces draw calls. When objects are marked as static, Unity can combine their meshes into larger batches, allowing the GPU to render them more efficiently in a single pass. To further reduce draw calls and improve rendering performance, combine multiple small objects into a single mesh, ensuring that each combined mesh has several hundred triangles and uses only one material for the entire mesh. This technique minimizes the number of times the GPU has to switch materials and render separate objects. Implement level of detail, or LOD, systems to dynamically adjust the detail of textures and models based on their distance from the camera. This optimization technique ensures that objects far away are rendered with lower detail, saving computational resources, while objects closer to the camera maintain high fidelity, optimizing overall rendering performance without sacrificing visual quality. Optimize textures by using compressed formats and opting for 16-bit textures over 32-bit when visual quality allows, as this reduces memory footprint. Additionally, combine multiple smaller textures into atlases to reduce draw calls, as the GPU can render several textures in a single batch, improving rendering efficiency. Bake lighting instead of relying solely on dynamic lighting to significantly reduce computation each frame, as baked lighting is pre-calculated. Furthermore, limit the number of real-time lights in your scene and carefully optimize shadow settings, as both dynamic lights and high-quality shadows can be very performance-intensive. Utilize occlusion culling to reduce visible geometry and draw calls in complex static scenes with many occluding objects. This technique prevents Unity from rendering objects that are hidden behind other objects from the camera's perspective, saving significant rendering resources and improving frame rates. Use a fixed time step for game updates to ensure consistent physics and logic computation, regardless of frame rate variations. This setting, found in Unity's project settings, guarantees that physics calculations occur at regular intervals, preventing erratic behavior and ensuring a stable and predictable game simulation. Disable idle animations by disabling the animator component directly on the game object when the animation is not needed. It's important to note that simply disabling the entire game object will not achieve the same optimization, as the animator component might still consume resources in the background. Simplify canvases by avoiding hugely nested transforms that are constantly moving around in the UI, as this can be a significant performance drain. A flatter hierarchy and minimizing dynamic UI elements can greatly improve UI rendering performance, especially on mobile devices. Switch the scripting backend from Mono to IL2CPP for better runtime performance in your Unity projects. IL2CPP converts C# code into C++ code, which is then compiled into native machine code, resulting in faster execution speeds and improved memory management compared to the Mono backend. Regularly profile your game's memory usage during development to identify and address memory leaks or excessive memory consumption. Unity's Profiler provides detailed insights into memory allocation, helping you pinpoint objects that are consuming too much memory or are not being properly released, which can lead to performance degradation over time. Use appropriate data structures that maximize performance and minimize memory overhead, such as arrays or fixed-size structures over dynamic lists when the size of your data is known. Arrays, for instance, offer contiguous memory allocation and faster access times compared to dynamic lists, which can incur overhead due to resizing. Understand how garbage collection works in C# and write more efficient code regarding memory management to minimize its impact on your game's performance. Reducing unnecessary object allocations and deallocations can significantly decrease the frequency and duration of garbage collection pauses, leading to a smoother gameplay experience. Avoid common scripting pitfalls like update, overuse, or excessive allocations during gameplay. Instead, move initialization code and logic that doesn't need to run every frame to start and awake methods when possible, as this reduces the computational load in your main game loop and improves performance. Implement asynchronous loading to load assets in the background without freezing the game, ensuring a smooth user experience. This technique allows your game to remain responsive while large assets are being loaded, preventing frustrating pauses and improving overall player satisfaction. Use efficient string method overloads and avoid creating many temporary string instances, as string operations can be performance intensive due to their immutable nature. When performing frequent string manipulations, consider using String Builder for better performance, as it allows for mutable string operations without constant reallocations. Begin with small, manageable projects to build a solid foundation in both coding and optimization techniques before tackling more complex endeavors. Starting small allows you to master fundamental concepts and best practices without being overwhelmed, setting you up for greater success in larger projects. Prioritize gameplay over graphics initially. A fun game with simple visuals is often better received and more engaging than a beautiful but unplayable one. Focusing on core mechanics and user experience first ensures that your game is enjoyable and visual enhancements can always be added later. Playtest your game early and often to identify and fix issues before they become deeply embedded problems in your codebase. Regular playtesting provides valuable feedback on gameplay, performance, and bugs, allowing you to iterate and refine your game throughout the development cycle. Engage with the game development community for support, insights, and valuable feedback on your projects. Online forums, social media groups, and local meetups are excellent resources for learning from experienced developers, sharing your progress, and getting constructive criticism that can help you improve your skills and projects. Most importantly, make it a priority to finish your projects to gain invaluable experience, rather than just starting many without completion. Completing a project, no matter how small, teaches you the entire development lifecycle from conception to deployment and provides a tangible portfolio piece. By diligently integrating these code optimization techniques into your development process, you can consistently create efficient, high-performing applications and games in both Visual Studio and Unity 3D. This comprehensive approach will not only improve the quality of your software, but also enhance your skills as a developer, leading to more successful and enjoyable projects.